Biosensors are small-sized devices. They consist of what we call the transduction. They also are closely connected with some biological molecule. The biomolecule interacts with the analyte of interest, and once the interaction takes place, there is a message that is amplified through the electronics, and they tell us what it is. And a very good example, of course, is the glucose monitor. Typically, the glucose monitor has a mostly electrochemical transduction, closely connected with an enzyme called glucose oxidase. The glucose oxidase combines with the glucose in the blood, and there is two compounds that are produced. One is gluconolactone, and the other is hydrogen peroxide. The gluconolactone is not electroactive, but if we measure the hydrogen peroxide, we can indirectly determine how much of glucose is present in the blood. And so that is a very good example of biosensor. Pain biosensors are going to be necessary for us to objectively measure pain. Pain is individual. In fact, the International Association for the Study of Pain defines pain as what this individual tells you. And if we continue to measure and assess pain the way it's currently being done, we're likely to exacerbate the issue of opioid crisis. And so what we need to look at is create objective measure of pain. For example, we have devices like glucose monitors that help to measure objectively the level of glucose in people's blood. Why is it that we cannot look at biomarkers of pain and design similar devices to help us assess pain? And that is the reason for my work in pain biosensors. It's based on looking at cyclooxygenase 2. Cyclooxygenase 2 is an enzyme that catalyzes the conversion of arachidonic acid into prostaglandins. Anytime you have prostaglandins, there's going to be pain. These are inflammatory markers. And so we now design a sensor that will measure the COX-2, cyclooxygenase 2. That's one example. COX-2 has been around, he's been known for many things. He's been implicated in inflammatory diseases, osteoarthritis, neurological diseases, cancer. And so by focusing on COX-2, over the years, there had been substrates developed to bind to that molecule. For example, Advil, Vioxx, Bextra, although there are issues with all of those molecules, but they've been designed many times to understand. So if we understand the biochemistry of some of these pain inflammatory markers, then we can design sensors for it. That's how they work.